Today we're going to continue our introduction to polar coordinates, and in the table you can see the formulas that we used yesterday. And then we have 3 additional properties that we're going to cover today, including the distance between 2 points on the polar coordinate plane, and then the polar equation for circles, and then the polar equation for lines. But first we're going to find r given theta. And in this case, we'll have 2 different angles. First, we'll start with pi over 6. So this graph is here just to show you where the angle is, and we're finding the r value of that point on the pink graph. And the pink graph represents the graph of r equals 4 over 1 plus sine theta, and that's the graph of a polar parabola. Essentially, all we're going to do is substitute into our equation where we see theta. We're going to substitute in first pi over 6, and then later we're going to substitute in pi. So you should be thinking of your unit circle when we figure out what is sine of pi over 6. And so sine of pi over 6 is equal to 1/2. And then 1 plus 1/2 is equal to 3/2. And now you just need to simplify. So if I were to multiply by 2 over 2, that would give me 8 over 3, and then that's my r value. Now we're going to do the same thing with the angle being at pi, which is this angle over here, and that point on the pink graph, which is the polar parabola. So we're going to do the same thing. We're going to do 4 over 1 plus sine of pi, and if you think back to your unit circle, sine of pi is the y coordinate, which would be 0, so 4 over 1 plus 0, which is 4 over 1, and that's equal to 4. All right, so now we're going to check to make sure we have the correct answers using our calculator. So first thing I'm going to do is make sure that I am in radian mode, so make sure that the word radian is highlighted. And then I'm just going to quit out of that and go to the main screen. So I'm going to hit alpha and then y equals, and that allows me to type in a numerator and denominator. So I'm just going to make my expression look exactly like 4 over 1 plus sine of theta, and then the first angle we're going to check is pi over 6. And then when you have it typed in, just hit enter, and that is equal to 8/3, so that is good. And then for my second equation, I'm just going to hit second and enter so that it'll pull up my previous entry, and I'm just going to change this to say 4 over 1 plus sine of pi, and that should give me 4. So now I know that I'm correct for both of those answers. We're going to do the same thing for number 2. We're going to now use the equation r equals 2 cosine of 2 theta, and we're going to substitute in 5 pi over 6 into theta, and 5 pi over 6 is over here, and we are finding the r coordinate for that point, and that is the picture of a polar rose. That's what you call that graph, by the way. And so we're going to think back to our unit circle again. So we have 2 times cosine of 5 pi over 3. So what is the x coordinate of the point at 5 pi over 3? And that is equal to 1/2. So 2 times 1/2 is equal to 1. For my second angle, we're just going to do the same thing, but we're going to now substitute in 3 pi over 2. So I have 2 cosine of 2 times 3 pi over 2. And so my 2's cancel out, and we have r equals 2 times cosine of 3 pi. So think back to your unit circle. This goes all the way around the unit circle 2 pi plus an additional pi. So you're thinking of what's the x coordinate of a point at pi on the unit circle. And so that would be -1. And 2 times -1 is equal to -2. All right, so just like with problem number 1, we're just going to type in the equation exactly the way that we see it on the paper. And we're going to do 2 cosine of 2 times. And then we just need to put in our angle, which is 5 pi over 6. And if we do it correctly, we should get the answer to be equal to 1. And then we're going to do the same thing. So I'm going to hit second and enter, and I'm just going to change 5 pi over 6 to be 3 pi over 2. And if we do it correctly, then we should get -2 as our answer. So now I've confirmed from the calculator that I did do the work correctly by hand. For problem number 3, we're going to find the distance between 4, 4 pi over 3 and 1, 0. So we're going to use the distance formula for this problem. We're going to start with the generic equation for the distance formula in the polar coordinate plane, and then we just need to make sure we label correctly. We know that ordered pairs are r comma theta, but we need the first point to be r1 theta 1 and the second point to be r2 theta 2. And it doesn't matter which point you label as point number 1 versus point number 2. So at this point we're going to substitute in, so we have the distance squared is equal to 4 squared plus 1 squared minus 2 times 4 times 1 times cosine of, and then now notice that this is angle 2 minus angle 1, not the other way around. So this is 0 minus 4 pi over 3. And so we have distance squared is equal to 16 plus 1 minus 8 times cosine of negative 4 pi over 3. All right, so now we have to think to our unit circle. How much is the x-coordinate of a point at negative 4 pi over 3, so that ends up in the second quadrant. Our x-coordinate is negative 1/2, so I have 16 plus 1 minus 8 times negative 1/2, and that becomes 17 plus 4, which is 21. And then we just have to take the square root of both sides, and because it's a distance, then it has to be just the positive square root of 21. So I would recommend checking this one also on the calculator. Just type in what you have for your initial equation once you've substituted in the values. So we have 4 squared plus 1 squared minus 2 times 4 times 1 times cosine of 0 minus 4 pi over 3. And we should get 21, and then we know we would take our square root of 21 from there. Just to make sure that we've calculated our values from the unit circle and simplified correctly. Problem 4, we're going to use the polar equation for circles to do the problem. And notice here that the radius is a. And what we're going to do is we're going to keep the r and the theta in the equation because those are going to be our variables. We're just going to substitute in for r sub 0 and theta sub 0 and a. All right, so here's our equation. We need to remember that 4 and 2 pi over 3 are r and theta, and then since we only have one point, we're going to call this r sub 0 and theta sub 0. And our 2 is actually our a in our equation, so it's going to be equal to 2 squared. So if we substitute everything, we get r squared plus 4 squared minus 2 times r times 4 times cosine of theta minus the angle that was in the ordered pair. So that's minus 2 pi over 3. And now we just need to simplify. So we have r squared plus 16 minus 8r. And then for cosine, we're going to leave it as cosine of theta minus 2 pi over 3, and 2 squared is equal to 4. So we could move a little bit of this around. We can subtract 16 from both sides, but then you can leave it as r squared minus 8r times cosine of theta minus 2 pi over 3 equals negative 12. As a reminder, keep r and theta as variables, and your radius gets substituted in for a. For our last problem, we're going to look at the polar equations for lines, and we're going to use this equation as well as this ordered pair for the foot of the perpendicular. As a reminder, the foot of the perpendicular from geometry is the point at which the perpendicular intersects with the line. For part A, since we're specifying the perpendicular distance from the origin to the line, and our equation is set up exactly like the generic formula, we're just going to look at what it's equal to, and since it's equal to 2, that's our distance. So we're done with part A. For part B, it says to determine the polar coordinates of the point on a line corresponding to theta equals 0, and then theta equals pi over 2. So for theta equaling 0, we're just going to substitute. So we've got r times cosine of 0 minus pi over 6 is equal to 2, and we just need to simplify. So we've got r times cosine of negative pi over 6 is equal to 2, and now we need to think about what would happen on our unit circle. So now think to your unit circle, what is the x-coordinate of a point at negative pi over 6, and that would be positive square root of 3 over 2. And then we just need to solve for r. So it's 2 times the reciprocal of that, and that gives us 4 over square root of 3, which is equal to 4 square root of 3 over 3. And since it asks you for the ordered pair, That's my r, and it's r comma theta, so we have 4 root 3 over 3, and theta is equal to 0. For theta equaling pi over 2, we're going to do the same thing. So we have r times cosine of pi over 2 minus pi over 6 is equal to 2. And so when we subtract, we've got 3 pi over 6 minus 1 pi over 6. 2 pi over 6 reduces to pi over 3. And so we think about what's the x-coordinate of our point at pi over 3, and that's equal to a half. R equals 2 divided by 1/2. You could multiply top and bottom by 2, and that would give me 4 over 1, which is equal to 4. And so my r comma theta is 4 comma pi over 2. So for part C, it says to specify the polar coordinates of the foot of the perpendicular from the origin to the line, and that formula is that it's always d comma alpha. And so the distance being 2 and the angle being pi over 6, that gives us the coordinates of that point. So for part D, it asks you to just sketch the line. And if we look at our ordered pair at 0 radians, it should be at 4 root 3 over 3. And if I get a decimal approximation for that, that's about 2.3. So on my x-axis, I should be at about 2.3. That's my x-intercept. So rectangularly, that would be 4 root 3 over 3 comma 0, because 0 radians is on the positive x-axis. And then pi over 2, that's on the positive y-axis, and we would be at 1, 2, 3, 4. So 0 comma 4 would be my y-intercept. And then if I just connect those 2 points, that's a sketch of my line. If I just connect those 2 points, then that's a good sketch of my line. So now for part E, it asks you to find the equation of the line in rectangular form, meaning it has to have x's and y's. And if I know that my x-intercept is 4 root 3 over 3 comma 0, and my y-intercept is at 0 comma 4, then I could find the slope. So my slope between those 2 points would be 4 minus 0 over 0 minus 4 root 3 over 3. That would give me 4 over negative 4 root 3 over 3. If I want to multiply by 3 over 3, that would give me 12 over negative 4 root 3. And I'm going to rationalize, so I'm going to multiply by root 3 over 3. So that's going to give me 12 root 3 over negative 12, and that reduces to negative root 3. So that's my slope, and since I have my slope and my y-intercept, I can do negative square root of 3x plus 4, and that's the equation of my line. The other way to find the equation of the line is to use the original equation of r cosine theta minus pi over 6 equals 2 and use the sum and difference formulas from the trig identity sheet from chapter 9, and you can expand it, and you could do r times, it would be cosine theta times cosine pi over 6 plus sine theta times sine of pi over 6 equals 2. And if I distribute my r, then I've got an r cosine, and cosine of pi over 6 is square root of 3 over 2. And I've got an r sine, and sine of pi over 6 is 1/2. So we can substitute in for r cosine, that is x, and r sine, that's y. So I can change this to be root 3 over 2x plus 1/2 y is equal to 2. And if I want to, I could leave it like that, because that would be in rectangular form, or I could solve for y and I would get the exact same equation that I got up here. All right, so that's it for today's notes. Have a nice day, and if you have any questions, please ask your teacher.